Hey everyone, today we're going to finish up section 1.3. We're looking at mins, maxes, increasing, decreasing intervals, and also end behavior for our finishing up describing polynomial functions and investigating functions. So we're going to start at the bottom of page 16 where it's just min and maxes. So when you're looking at the graph, we locate the minimum and maximum using the x values. You can also write and y values, or the ordered pairs. Maxes are the high points on the graph, and the minimums are the low points on the graph, which kind of makes sense. Maxes are high, mins are low. It is possible that we will not have mins or maxes for some graphs, just based off, we'll see some examples for that. So for letter A, it says state the minimum and maximum for the values of the graph. For letter A, notice there's an arrow here, so it's going down, and it's going down forever. So there's not one single point that would be a minimum. So we do not have a minimum here. So we can just write minimum NA. For our maximum, if you notice on this side, there's no arrow, there's a point. So this point right here is the highest point we have. So I'm just going to write that as an ordered pair. And it's 3, 3. All right, for letter B, again, minimums are always the lowest points, maximums are always the highest points. So if we look minimum, a low point, if we're looking to see how low our graph goes, right here, the graph doesn't go any lower than right there. So that would be our minimum, and that would be a minimum at -3, -7. In terms of maxes, our high points, again, notice we have arrows here. So it's going to keep going up forever. So there's not one single point that works because it keeps going up forever. So that would be our not applicable or no max. Now the difference between B and C is that for C, we don't have arrows on our parabola. So therefore, we are going to have both mins and maxes in this case. And again, our min are lower points. And if you notice, these are both low points right there. And they are equally low. So in this case, we're actually going to have two minimums. So we're going to minimum at -2, -5, and also at 4, -5. And then in terms of our maximum, it's a high point. So the highest the graph goes is right here, which would be 1, 4. All right, so that's mins and maxes. Basically, you're just looking for high points and low points. All right, so we're on to page 17 now. And for page 17, we're going to learn about increasing and decreasing intervals. And to do that, we're also going to learn something called interval notation. And interval notation, just a shorter way of writing inequalities. You can use it when you're solving inequalities. Domain and range, we can also do interval notation. And also, especially this describing when the graphs increase or decrease. So here's a table of inequalities, as well as then the interval notation equivalent. So if you notice, when it went from -2 is less than x, which is less than 5, which is like something kind of like a domain or range we've just been looking at, interval notation, it looks like parenthesis -2, 5 parenthesis, where if we're saying 3 is less than or equal to x is less than or equal to 10, we now would write that as bracket 3, 10 bracket. If we were to have something like -4 is less than x, which is less than or equal to 12, that interval equivalent would be parenthesis -4, 12 bracket. And if we look at 0 is less than or equal to x, which is less than 2, we'd have bracket 0, 2 parenthesis. So with that being said, and I'll come back to these other four in a second, what do you notice about the difference between brackets and parentheses? Well, here there were no equal to signs, they were all parentheses. Here they were all equal to signs, they were brackets. For this one, there was no equal to, and that had a parenthesis. Here it had an equal to, and it was a bracket. And here when we had an equal to, it was a bracket first, not equal to parenthesis. So a bracket means equal to, or less than or equal to, and parenthesis means just the not equal to, or means less than. Okay. Now if we go back here, this says x is less than 5. And then our interval notation has parenthesis, negative infinity, comma 5, parenthesis. And there's no infinity in this original one. But remember what we're doing here. This is saying x is less than 5. So if we would write this as a compound inequality, anything less x is less than 5, you're saying less than 5. Well, what's the lowest value if it's less than 5? It would keep going low forever. The lowest it gets is negative infinity. So this is equivalent to that, which is equivalent to that. And just remember, you can never equal your infinities. Therefore, that's why we have the parenthesis rather than the bracket. And if we look at x is greater than or equal to negative 3, greater than or equal to negative 3 says that negative 3 would be my smallest. So I could write that as negative 3 is less than or equal to x. And then the largest that x could be, since it has to be greater than or equal to negative 3, it'd keep going up forever. So the largest would just be infinity. So that's where we're getting this. The bracket because it's less than or equal to, and then the infinity because it goes up forever, and then the parenthesis because you can never equal infinity. Similar, x is greater than 7, so 7 would be our smallest. We wouldn't have the equal to because it doesn't have it originally, and it goes up forever. And then the last one, x is less than or equal to 0. The largest it could be is 0 or equal to 0, and then the smallest it would go down forever. So again, this is equivalent to that, which is equivalent to that. All right, we talked about this briefly. Can you ever reach infinity or negative infinity? Remember, you cannot. So therefore, you're always using parentheses when dealing with your infinities. And if you notice, that's what we had here, parenthesis, 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 parenthesis for all those infinities. All right, here's a little bit of practice we have going on. So these are just regular inequalities from Algebra 1, but we're going to see how this relates to interval notation. So if we looked at the equation, or the inequality 3x minus 7 is less than 14, we're solving for x, so we'd add 7, which is getting 3x is less than 21, divide that by 3, and we will get x is less than 7. Now, it does say write an interval notation, so if we're going to write that interval notation, it's saying x is less than 7. So remember what that means is that 7 is your largest, and it's every number less than that, so it would go down to negative infinity. Again, you can never equal the infinities, so it's a parenthesis, and since we don't have an equal to with the 7, it would be another parenthesis. So it would be parenthesis, negative infinity, comma, 7, parenthesis. If we look at the second one, we would have to subtract 2 first and get negative 4x is less than or equal to 16, and then divide by negative 4. Just remember, when we're dividing by negative 4, you must flip the inequality sign when you divide by a negative. So we get x is greater than or equal to negative 4 in this case as our final answer. And then when we go and write our inequality, greater than or equal to negative 4 means negative 4 would be our smallest value. It's equal to, so I'd use a bracket, and it would go up forever, so it would be a parenthesis. And then our last one, the compound inequality. Just remember, you have to do the same thing to all sides. So I'm trying to get the x by itself, but I have to add 6 now to all sides. So I get 10 is less than or equal to 2x, which is less than 16. Then I would divide everything by 2 to get the x by itself, which would be 5 is less than or equal to x, which is less than 8. If I'm going to write that as a compound inequality, I would put my 5 first, then my 8, and I need a bracket near the 5 because it's equal to, and a parenthesis around the 8. All right, we can also do domain and range with this. So for right now, I don't care whether you use the inequality notation or the interval notation for domain and range. It's up to you. But interval is a little bit easier, and I'm going to be expecting to use that for what we're coming up with. So you might want to get used to the interval notation. But if we're going to practice the domain and range, just remember this graph goes to the left forever, and it goes to the right forever, do those arrows. So it's all real numbers as our domain, and the way we write all real numbers in terms of interval notation is using negative x. Now you always do want to, the difference here is you want to put your x in front now, because we still want to define what domain is, x or y. So for domain we're going to put an x, and it's going left to negative infinity and to the right to positive infinity, so we put the parentheses around each one. And in terms of our range, it is going down forever, so that's where I'm getting the negative infinity and never equaling it. And then it's going to go up and stop right here, which is the y value of 4, and it touches the y value of 4, so I have a bracket there. Again, notice I put that y in front because I have to define what variable I'm using for domain and range. All right, as we look at the next one, the next one's a little trickier because we have a whole, meaning, again, not equal to, and a closed dot, which means equal to. So when I'm looking at my domain, how far left does it go? It goes left to negative 2. But again, it doesn't equal negative 2. It gets really close to it, but doesn't touch it because of that open dot. And it goes right to 1. So the way I'd write that, again, I put my x to define that's a domain. It goes left to negative 2 with a parenthesis and right to 1 with a bracket. And then my range, how low does it go? It goes down to negative 4. It goes up to 5. But again, it doesn't touch the negative 4, but it does touch the 5. So we have y, defining our variable, parenthesis negative 4, comma 5 bracket. So again, that's saying all the values between negative 4, but not including negative 4, to 5, and including 5. And then last but not least, we have this graph. It goes left to negative 3, right to infinity, and it touches the negative 3. So we'd have bracket negative 3, comma, parenthesis, comma, infinity, parenthesis. So every value greater than or equal to negative 3. And then for our range, it goes down to negative 4, touches it. So I bracket negative 4 and goes up forever. All right, so next thing we want to look at, since interval notation can look like coordinates, because it's in using parentheses sometimes, how can you distinguish between the two? So in other words, how would you know if 3, 6 represents a point on the graph or the interval from 3 to 6, not including either number? So you got to look at, just have to use some of your context clues. So first off, in an interval notation, just remember the smallest number always comes first. So in this case, the smallest number is coming first, but let's just say you had something like parenthesis 6, comma 1, parenthesis. That has to be a point because the larger number is coming first. And in interval notation, your smallest number always has to come first. So you know that's a point. In terms of something like the 3, 6, like we have here, you just have to look at the context of the problem. If it's saying state the domain and range, you know that would be an interval. If it's saying plot the point, you know it's a point. If it says find the area of increasing and decreasing, again, you know it would be an interval. So you really look at the context, but it's also good to know that the smallest number always has to come first. All right, on to our increasing, decreasing. So when reading a graph, just like a book, you read from left to right. Don't forget, we're going to use interval notation. That's why we learned it. Identify the increasing and decreasing intervals, and if there's a min or a max, circle which one and state that value. So we're going to do that right here. So we have a graph, and increasing means it's going up from left to right. So we're always going to start on the left, and in this case, our graph is going up in the beginning. So that means we're talking about the increasing to start. And we are always stating the x values. We're always reading, when we're doing increase and decreasing, we're stating the interval of the x values that it increases or decreases on. So this graph is increasing. There's an arrow here. So I could start as far left as possible. It's increasing as far left as possible. That's where we'd start. So negative infinity. And it increases. If you think about a guy running up a hill, here's Rocky Balboa. Adrian, he's running up the hill. He's got to the top. Yeah, he's waving his hands up high because he got to the top of the hill. So he's at the top of the hill right now. What x value is that at? That is at the x value of negative 5. So we are increasing in this graph from x values from negative infinity to negative 5 Notice the one key thing here is we have parentheses. So we're always using parentheses for increasing and decreasing, because when we're at the top, when x is -5, we're at the very top of that hill and it's flat. It's not increasing anymore. So you kind of have to remember that if you ever ran up a hill, when you get to that very top, it's flat. It's a great feeling to be up the top, but it's flat. You're not increasing anymore. Same thing with this. You're increasing until you get to the very top, which is at an x value -5, but it's flat up there, so we're not equaling the -5 in our increasing interval. And then after right one step past the -5, like -4.99999, it starts to decrease. So therefore, instead of writing 4.999, we're just using a parenthesis. So parenthesis -5, meaning it's really close to -5, but not equal to. And it's going to decrease again. If we're looking for the x values, there's an arrow, so it's going to keep going right forever, and it's going to keep decreasing while it's going to the right. So we're decreasing from x values from -5 all the way forever to the right infinity. In this case, we do have a maximum because we have a high point. We do not have a minimum because there's arrows pointing down. And we have a maximum right here at -5, 2. All right, a couple things. When a function is increasing, the graph goes up from left to right, which we talked about. Increasing here is going up from left to right, and when it's decreasing, it goes down from left to right. All right, taking a look at two more examples here. For number 2, notice we're starting on the left and it's going down to start. So down, remember, is decreasing. So therefore, I'm going to write my decreasing interval first. So again, I always put that x in front to note that I'm using the x values here. So I could start as far left as possible, which would be -infinity. And I'm decreasing from -infinity, the x value is a -infinity, and it's decreasing, decreasing, decreasing until I get to right here. And again, we're always using our x values, so it stops decreasing at the x value of -3. And again, once we get to -3, it's no longer increasing. So therefore we have, no longer decreasing. So therefore we have the parenthesis, not a bracket. Right after that -3, like -2.99, it starts to increase. So again, the way we're writing that is we're putting our x value there to note we're using the x values. We put a parenthesis for -3, and then it's going to increase forever. And again, we're looking at the x values for that, so it's increasing to +infinity in the x values. In this case, we do have a minimum, and that minimum is at the point -3, -1. If we look at the third one, in this case, I can start to the left, and I'm just be walking up a hill forever. So therefore, there is no decreasing, and we are increasing from the x values of -infinity to +infinity. In this case, again, since there's no distinct low point or no distinct high point, we do not have a min nor a max. All right, on to page 19. And with page 19, we're going to start with what we call end behavior. And end behavior just tells you what happens at the end of each graph. The left end, the right end. Are both ends going up? If they are, you would use these double up arrows. If both ends are going down, you'd have the double down arrows. If they're going in opposite directions, you'd have either up, down, if it's up on the left and down on the right, or you can also have down, up, down on the left, up on the right. So if we look at letter A, on the left, the arrow is pointing down. On the right, the arrow is pointing down. So this would be down, down in behavior. For letter B, we have up on the left and up on the right. So this would be up, up in behavior. And for letter C, it's pointing down on the left. So it'd be down, up on the right, down, up in behavior. All right, I want you to try this practice on your own. Pause the video, try that practice on your own, and come back once you have it finished to check your work. All right, hopefully you had some time to work on that. If we look at letter D here, as we're going through this, we always start on the left. And in this case, we are going down, so we're decreasing to begin with, and then increasing after that. So we would be decreasing from negative infinity, again, the x values from negative infinity to -6, because it's decreasing from here to here. It stops decreasing right there, which is the x value of -6. Again, I think it's very important to put that x in the front to note that you're using the x values here. And then after that, it starts to increase. So it begins increasing right after -6, so parenthesis -6, and increases forever, which would be the parenthesis. Our end behavior is up, up, and in this case, we do have a minimum at 6, -6, -3. For letter E, this one, it's only increasing the whole time, so it would be increasing from the x values from negative infinity to positive infinity. It's never decreasing because it's never going down. Our end behavior would be down, up, because it's down first and up on the right, and then we do not have a min or a max. And last but not least, letter F, we would have increasing to begin with, because it's going up the hill, so it's increasing from x values between negative infinity. It stops increasing right here. And just be careful, because again, we're always using the x value. So what x value is right here? It's the x value of 0. So it's increasing from negative infinity to 0, and then decreases after that. So that's from x values from 0 to infinity, or when x is greater than 0. Again, always using the parentheses for increasing, decreasing, because you're never equal. It's flat at that point. In this case, our end behavior is down, down, and then we have a maximum at 0, 4. All right, if you have questions, let me know.